Hey guys, Miss Peterson here, and welcome to our chemistry lecture on periodic trends. In this lecture, we're going to be going over the trends of the periodic table, how these atoms vary in atomic radius, electronegativity, ionization energy, and ionic radius. Okay, so let's get started. Now, we have to remember that this all goes back to Coulomb's law of attraction. Okay, in our atom, we have that positively charged nucleus that's attracted to the negatively charged electrons. And the stronger the charge in that nucleus, and the closer those electrons are to that nucleus, the stronger the force. So, let's start with atomic radius. Now, atomic radius just refers to the size of an atom's electron cloud. Okay, so the general trend for it is as you go down a group on the periodic table, the radius increases, which makes sense, okay? Hydrogen has 1 energy level. Lithium has 2 energy levels. Sodium has 3 energy levels. So you're just adding layers of electrons as you go down that group. So you're gonna have a bigger radius. Now, the trend for periods is a little more nuanced. So as you go across a period on the periodic table, like say you're going from lithium to beryllium, okay? Lithium has 3 protons and 3 electrons in its 2 energy levels. But beryllium has 4 protons, okay? And still only 2 energy levels. So that extra proton of beryllium attracts in those electron clouds, okay? And the electrons are all spread out in the atom, so they don't exert their force together. That nucleus acts on each electron independently and pulls it in. So as you go across a row on the periodic table, because you're filling in electrons in the same energy level, but you're getting more and more and more positive charge in that nucleus, the atoms get smaller. Okay? So based on that, as you go down a group, the radius increases. As you go left to right, the radius decreases. So as you go that way, it increases. Who has the smallest radius on the periodic table? Well, it's either going to be hydrogen or helium because they both only have 1 energy level. But hydrogen only has 1 proton to pull in that energy level. Even though its 2 electrons are going to repel each other a little bit, that's still not going to make it smaller than helium. Helium has 2 protons to pull in that layer of electrons. So helium is the smallest element on the periodic table. Okay, so up in that corner. So who do you think is the biggest? Yeah, okay, it's gonna be the one down in this corner. Remember, these elements are actually inserted up in there in the periodic table. So francium, with its 7 energy levels and only 87 protons to control them, has the largest radius of any elements on the periodic table. Okay, cool. So if you want to look at it visually, here's a visualization showing you those relative sizes. So you can see that atomic radius increasing as you go down and as you go right to left. Okay, with helium being the smallest, and they don't have francium on here, they only have cesium. They're missing a bottom row of the table, but francium would be the biggest. Okay, cool. Okay, cool. Let's do some practice. You got this. Which atom is going to have the larger radius? Magnesium or calcium? Yeah, you got it. It is calcium, okay? Because calcium has 3 energy levels and magnesium only has 2. Okay? But a little harder, which one will have the larger radius? Carbon or oxygen? Okay? Just for fun, let's go ahead and draw their Bohr models. We have carbon with its 6 protons and oxygen with its 8. Okay, they both have 2 energy levels. Oops, don't want to be overlapping. 2, with 2 electrons in the first. And then carbon has 6 total electrons, so 4 valence electrons in its outermost shell. And oxygen is in group 8, so it has 6 valence electrons. Or sorry, group 16, so it has 6 valence electrons in its outer shell. 8 total electrons. Sorry about that. right? So this +8 charge serves to attract in these electrons that are the same average distance away as these electrons. But that charge of +6 isn't as strong. Okay, so oxygen is going to be smaller. Carbon is going to be bigger. Okay, cool. Okay, cool. Get that back right. All right, let's move on to electronegativity. So electronegativity refers to the ability of an atom to attract another atom's electron when they get into a chemical bond. Okay, so electronegativity can only really be measured when the atoms are bonding. So our noble gases over there, our group 18 elements, they don't have electronegativity values because they don't form chemical bonds normally. So helium, neon, argon, no bonds, no electronegativity values. Now, we are able to get them for krypton and xenon, who form some large compounds, but in general, group 18, not very reactive. So what about the trend, okay? Let's think about the trend as you go down a group. Well, as you go down a group, the electronegativity is going to decrease, okay? They're going to get less able to attract another atom's electron. Why? They're getting bigger, okay? Their nucleus is getting farther away from those other electrons they want to attract. So the electronegativity, the ability to attract those electrons, decreases as the atoms get bigger, which also explains the trend across a period. Okay, as you go across a period, the electronegativity is going to increase because you're going to have more protons and a smaller radius. Just like those more protons are better at attracting in their own electrons, those more protons are also good at attracting other atoms' electrons. Okay, so as you go across the period, the electronegativity will increase. Meaning, who's the most attractive element? Well, we know it's going to be up in this corner because it increases that way and increases as you go up. But helium and neon don't have it, so it is going to be fluorine, okay? Fluorine is the most attractive on the periodic table, which leaves big old francium to be our least attractive. Okay, cool. Okay, cool. Here is that visually. You can see fluorine being the most, it going from low to high and increasing as you go across the periodic table and as you go up. Okay, cool. Okay, cool. Let's practice with this one. Which atom do you think has the higher electronegativity? Sodium or chlorine? Okay, sodium and chlorine are in the same energy level. Okay, but chlorine is super close to fluorine, the most attractive element. Chlorine is also much smaller than sodium. Okay, so chlorine is going to be way more attractive. Okay, much higher electronegativity. But if we were comparing, say, chlorine and bromine, okay, which element there is more attractive? It's still chlorine, okay? Chlorine has less energy levels, so chlorine's going to be smaller and therefore more attractive. Okay. Now, closely related to electronegativity is the ionization energy. Now, what the ionization, there shouldn't be an S there. What the ionization energy is the energy required to remove an electron from an ion. That's when we say an atom is ionized, when it's had an electron either removed or added, okay? Typically removed. So the energy required to remove that electron, okay? So as you go down a group, who do you think holds on to their electrons tighter? The ones up top with their small little energy levels, or the ones down bottom with their big old energy levels? Okay? Yeah, it's easier to steal from someone who has more energy levels. So the ionization energy decreases as you go down a group. Where As you go across a period, again, it's the opposite. It increases because the atoms are getting smaller. Okay, it's harder to steal an electron from helium, who's holding on to it tighter, than fluorine is with its 2 protons. Okay, the noble gases have really high ionization energies because they have an electron configuration that ends in ns2, np6, and they're like, that is super stable. So they're pretty happy. They don't want you to mess that up. They have very high ionization energy. It is hard to steal their electrons. Oh, and I just told you that answer. Which group has the highest ionization energy? Yeah, okay, it's the noble gases, group 18, the noble gases. Okay. And which one then will have the lowest? It will be the alkali metals. Alkali metals want to give you their electrons, okay? Their ionization energies are so low, they're negative, okay? They want to give you their electrons. Oh, and that's group 1. Group 1 is the alkali metals, okay? So here's a visualization of that. You can see, it's showing in kilojoules, so no, it is still positive, but you can see it being very low here and increasing as you go closer to helium on the periodic table. Okay, so which atom has a higher ionization energy? Lithium or sodium? Who's it going to be harder to steal electrons from? Yeah, lithium, okay? Lithium is smaller, so it holds on to its electrons tighter. What about chlorine or argon? Who's going to be harder to steal that electron from? Who has the higher ionization energy? Yeah, it's going to be argon, okay? Argon has that special electron configuration that's super stable, so it's going to be hard to steal its electrons. Okay, cool. Okay, cool. Now, let's talk about the last one, ionic radius. This we will get deeper into when we get into ion formation and ionic bonds and how ionic compounds form. But for now, ionic radius is just referring to the size of the ion formed by the atom. Okay? Now, when the metals, remember, are to the left of the staircase line on the periodic table. So when metals form ions, they lose electrons. And they typically end up dropping down an energy level when they do that. So they get smaller. But within the metals, the trend is similar to atomic radius, okay? They just get smaller when they form the ions. Now, on the right side of that staircase line, the nonmetals, when they form ions, they gain electrons, okay? And they're going to get larger due to that increased electronic repulsion between the ions. Okay, so these guys end up getting larger. Yep, and again, within them, it's the same as atomic radius. And we'll get deeper into that one when we get into ion formation and compounds. But you can kind of see that here with the metals. The gray circles is representing the size of the ion. So you can see the size of the ion getting bigger, but all being smaller than the size of the metal atom. Okay, where within the nonmetals, the ion is bigger, but again, the general trend is still the same as atomic radius. Okay. So, which ion will be larger? Lithium or sodium? Yep, okay, sodium. It's got more energy levels. And when fluorine forms an ion, is it going to get bigger or smaller? Okay. Well, it's a non-metal, so it's going to gain electrons and get bigger. Okay, cool. Okay, cool. That's it for our periodic trends.